Okay, let's look at a nuclear reactor and how it works. The first thing we need for a nuclear reactor is fuel. What we use for fuel is uranium 235. Okay, they are the little green rods you see Homer Simpson throw down in his back at the start of The Simpsons. Um, where do we get it from? There are deposits of it in rocks, so we have to mine it out. But the vast majority of the lump of uranium we get out will be uranium 238, the more common isotope. So what we do is we react that with fluorine usually or chlorine, make it into a gas, spin it round in these big centrifuges. The heavier 238 goes to the sides, the lighter uranium 235 goes in the middle. We then extract that. We do this process lots and lots of times until the amount of uranium 235 increases to 3%. Okay, and once it gets to 3%, we can then use it in our nuclear reactor. So our fuel rods will have at least 3% uranium 235, and what we do is we put lots of these in our reactor core. We then get a neutron to start the reaction, and then fission starts occurring of the uranium 235 nuclei. But we need to control that. Remember, we don't want it going where we get one reaction, then 3, then 9, then 27, then 81. We want it to be steady. So what we do is the neutrons that move across in between these fuel rods that could start another fission reaction, we have little control rods. And they can be lowered down in between the fuel rods to block essentially or absorb those neutrons so they can't go on to cause another chain reaction, and then that will lower the amount of fission reactions happening. If something goes wrong in a nuclear reactor, these control rods should just be able to drop in and stop the reaction from happening. So under normal circumstances, it should be quite safe. There have been accidents where these control rods haven't functioned correctly. In Fukushima in Japan, a tidal wave came in that stopped the motors that moved these up and down. Um, and then you get your uncontrolled reaction. What can happen is the heat can get so high in there if we don't control it that these fuel rods can melt. We call that a meltdown. And if they melt, then they can go to the bottom of the reactor core, and then it's very hard to control that reaction anymore. When that happens, we get explosions, we get leakage of this material. The uranium 235 fuel by itself isn't that dangerous because uranium is an alpha emitter. So in fact, to make uranium safe, all we have to do is wrap it in paper. The problem is the daughter nuclei. Okay, so if you remember, our uranium 235 splits in two. We had the example where these were barium and krypton. These emit radiation, not just alpha, and have very long half-life, so they'll emit radiation for a very long period of time. And eventually what happens is the uranium gets used up on these fuel rods, and we have to replace them. So we take them out, they're called spent fuel rods. They now contain the barium and krypton nuclei that are unstable, they're emitting radiation. We have to store that um, for a very long period of time, and it makes it expensive process. And it's those fuel rods, the spent nuclear fuel, that is one of the drawbacks to nuclear power plants. So we looked at some of the disadvantages in our energy unit. One of them was the risk of a leak, the risk of meltdown, the spent nuclear fuel, which is radioactive for a very, very long period of time, having to be stored, which is expensive. And the other thing is, at the end of the power plant's life, we need to decommission it. By that, we just mean we need to knock it down, maybe restore the land that it can be used for something else. With a coal power plant, we just use a wrecking ball, knock it down. We can even sell on the bricks to be used again. You can't do that for a nuclear power plant. We have to take it apart bit by bit meticulously, check everything to see if it is emitting radiation, if it's been contaminated. And if it is, we need to store it. You need specialized equipment, specialized personnel to do all that. It makes it an expensive process at the end of a power plant's life. We spoke about some other things in the energy booklet, such as Can it respond to changes in demand? Yes, because we can move these control rods up and down to generate more heat. Does it produce CO2? No, it doesn't contribute to global warming, although it does produce other waste. Is it reliable? Yes, as long as we've got the uranium fuel there, we can generate electricity. In fact, one of the biggest benefits of this is we get so much energy from these. So we only need a few kilograms of fuel to produce a huge amount of energy compared to coal, where you would need tons and tons and tons of coal to produce the same amount of electricity.